N5 tutorial section 17 is a look at Pythagoras at National 5, including converse of Pythagoras and Pythagoras in 3D. The first question we're going to look at is to find the length of x, which we can see is part of this triangle up here. Now, first of all, I'm going to have to find out this length here. So this is about applying Pythagoras twice. So I'm first of all going to call this side t, and t squared will be equal to 3 squared plus 4 squared. T squared is equal to 9 plus 16. T squared is equal to 25. T is equal to the square root of 25. And t is equal to 5. I can then apply Pythagoras again. And x squared is equal to 5 squared plus 12 squared. X squared equals 25 plus 144. X squared equals 169. X equals the square root of 169, and x is equal to 13. Okay, question 2 is a bit of converse of Pythagoras. Now, a converse Pythagoras question is slightly different from routine Pythagoras. Instead of looking for a missing side, you're given the 3 sides, but you're looking to see whether it's a right angle triangle. If it's a right angle triangle, then that's because Pythagoras works for the triangle that you have, using 3 numbers, 47, 27, 36. So the question is often in context. So if that's a flagpole and that's a piece of rope in red, the question might say, is the flagpole directly vertical from the ground, which would imply that this is a right angle in here. So that's the kind of context this question might be in. So we would apply Pythagoras and see if it works. 45 squared equals 27 squared plus 36 squared. That'll give me 2025 equals 2025. Now we can see there that Pythagoras worked. So left hand side equals right hand side. Therefore, triangle is right angled. And if the context of the question was something to do with the flagpole, we'd maybe say something like the flagpole is standing vertically. Now, just to kind of show you what would happen here if the numbers were slightly different. If instead of 45, this number up here was actually 48, then let's see what would happen then. So in this scenario, we would have 48 squared equals 36 squared plus 27 squared. That would then give us 2304 is equal to 2025. At that point, obviously Pythagoras didn't work, and I would need to revisit that statement. 2304 is not equal to 2025, which means 48 squared is not equal to 36 plus 27 squared. So LHS does not equal RHS. Therefore, triangle is not right angled. And again, if the context of the question was, say, for example, the flagpole, we would say something along the lines of the flagpole does not stand up vertically. Question 3, we're going to find the length of h without a calculator, and we're going to write the answer as a surd in its simplest form. So it's one of the shorter sides, so short side subtract for Pythagoras. H squared will be equal to root 50 squared minus root 32 squared. If you think about the square of a square root, the square root and the square cancel each other out, so the square root of 50 squared is 50. And the square root of 32 squared is 32. I then get h squared is equal to 18 and h is equal to root 18. So root 18 is a surd that can be simplified. When simplifying surds, a good idea is to get all the square numbers between 1 and 100, and we're looking for the biggest factor of 18 that's on that list. So checking through the list, the biggest factor that's on the list is, well, it's not note 4, but it's 9. So that's the square root of 9 times 2. Square root of 9 times square root of 2. Root 9 is 3. Final answer is 3 root 2. Question 4. We've got a circular shape with a part of the circle cut away and replaced with a horizontal line down the bottom, and we're looking to find the height of this shape. Now this is a Pythagoras problem that often comes up. The first thing that we're looking to do with this question is to see if we can use Pythagoras by creating a right angled triangle. That's quite easy to do. If I split down there, there's my right angled triangle. From here to here is half of the 6, and that's 3. So I could now call this side here x, and I'm looking for the shorter side using Pythagoras. So it's x squared equals 5 squared minus 3 squared. X squared equals 25 minus 9. X squared is equal to 16. X is equal to the square root of 16, and that's 4. So x is equal to 4. Now to find the height of the shape, we can see that the height of the shape is between here and here. Well, that part's 4. We know that the radius of the shape is 5, so no matter where I go in the shape with the radius, it's definitely 5. So this red line between here and here is 5. Between here and here is 4, so the height of the shape is definitely 5 plus 4, and that's 9 centimetres. Okay, with this question, we're doing Pythagoras in 3 dimensions. We've got a square base cuboid, so the question tells me that that's what we're dealing with, the square base cuboid. So this bit down the bottom is a square. We can see that the length of the square on the base is 4 centimetres, the height of the cuboid is 6. Now the question is to find the length of the space diagonal, AB, denoted by the blue line. So it's a space diagonal because it travels through space from one corner to another. Okay, so if between here and here is 4 centimetres, we know that this is also 4 centimetres since it's a square base. Now what I can do here is apply Pythagoras once to get the length of this green line. So I'm going to apply Pythagoras down here. So I'm going to call that line there G. So G squared would be equal to 4 squared plus 4 squared. We're going to say that this one is in a non-calculator paper, and to write our final answer as a surd in the simplest form. So G squared would be equal to 4 squared plus 4 squared, and G squared is equal to 16 plus 16. G squared is equal to 32. Now I can say that AB squared is equal to G squared plus 6 squared, and use Pythagoras again. So AB squared is equal to, well, G squared is 32, plus 6 squared is 36. AB squared is equal to 32 plus 36, which is 68. So AB is equal to the square root of 68. Now we're going to simplify that as a surd in its simplest form. So again, a good tactic is to get all the square numbers between 1 and 100. If I scan the list, the biggest one that goes into 68 is 4. So AB is equal to the square root of, and 4 fits into 68 17 times. Square root of 4 times the square root of 17, and that is equal to 2 root 17.